Welcome to our TCP IP session. Let's just type this in here, TCP IP. And we'll have a look at TCP IP version 4. Let me just type this down here. So it's version 4. Okay, first of all, let's get those letters a little bit bigger so you can see it better. And 20, yeah, that should be okay. And use my favorite font, which is this one. Okay, so that's what we'll be looking at today, TCP IP version 4. Let's start with a box standard number. And didn't do it, did it? Okay. So box standard number, IP address. We have got 192.168.10. And let's use 7 as an example. Okay, so that's a typical IP address, a so-called private IP address. And the first thing you need to understand about IP addressing is the numbers which you can use. So please follow the cursor. You can see we've got a number here, then we've got another number there, we've got a number there, and a number there. Now each number consists of 1 byte. Let me just show you what this byte looks like. Let's do a calc, and I can show you how you can manipulate IP addresses and sort of turn them into binary numbers. Okay, to be able to do this, you have to turn the calculator into scientific view, so it's a little bit bigger. And I'm just going to type in 192 just to make life easy, and then up here we can turn them into a different numbering system. And yeah, so we're going to turn them into binary. Try again, 192. Turn it into binary, and this is what we get. So we get this number, 1100 space, just to make it easier to look at, and then 4 zeros again. So that's our byte for 192. The next byte is 168. So we've got 1, 0, 1. Is this right? 168. So we've got 128, 32 is 160, and then we've got 8 as well. So we stick 1, 1, 1. We've got 10, which is 0, 0, 0, 0, and then we've got an 8, and we've got a 0, a 2, and a 0. So now 4 and a 2. Okay. And then the last digit is 7. So we're going to type in 0, 0, 0, 0, and then 0, 1, 1, 1. Okay, so we've got, let me just sort of type this on top of here so you can see which represents which number. So we've got 192, then we've got 168, we've got 10, and the last digit here, or the last octet here, is a 7. Right, what do we need to know about these numbers? So first of all, we can see this is a binary number. That's a decimal number, which both mean pretty much the same thing. Yeah, it's just a different way of expressing it. So first of all, in binary, when I set everything to 0, 0, let me just do this. And let's go down with the big font. So let's set everything in binary to 0, 0, 0, 0, 0. So that would be in decimal a 0. And if I set everything to 1, that's right. Doesn't quite space out that nicely as with the zeros. So 8 ones would be 255. Let me just go through here and then 255. So the point I'm making is the lowest number we can have in our octet is a 0, and the highest possible number we can have is 255. So you will never have an IP address, let's say 267, 168.10.7. It's not possible. So it has to be the highest number you can possibly deal with is 255. The lowest number is 0, as represented in binary. So we just use decimal to make life a little bit easier on us. Okay, I hope that's sorted out so far. Let's take this a bit further. So when we look at this IP address, we have got two parts to the IP address. Let me just, for this particular IP address, show you how this works. So we've got the first part here, the first 3 octets, and the first 3 octets are the so-called network portion for this particular IP address. It's a private class C IP address. We're going to look at this later. And the first part is just the network portion. The second part is the host portion. And in this instance, it would just be the 7. So how can we differentiate one from the other? Now, one thing you have to bear in mind, and this is what we are leading up to, this division could be anywhere along this line. And we could have anywhere the division line between network portion and host portion. Okay, how do we normally know where's a network portion, where's a host portion? It's quite important. Let's have a look. Let's put a couple of rules as well. Let me just write down a few rules and then you can look at this later. Okay, an IP address, that's the first rule, yeah? IP address consists, and I'm only talking about version 4 here, of 4 octets, that's what it's called, or bytes. Yeah. The second rule is the lowest number is 0, and the highest number, possible number, is 255. So just bear this in the back of your mind. So whenever you're dealing with IP addresses, you cannot have anything which is over 255. Let's do the next one, which is number 3, the next rule. Every IP address has a host portion and a network portion. To communicate, on the same network, all IP addresses need to have the same or identical network portion. Yeah, so when you look at this IP address up here, let me just highlight it again. We've got 192.168.10, and all IP addresses on my network need to have the same numbers in the network portion. Yeah, if they've got a different number, it doesn't work. They can't communicate. So that's a rule as well. The value for the host portion has to be unique for all hosts on the same, in the same network. Yeah, let's do it right, in the same network. Yeah, makes sense as well. So we've got the 7 here, and we cannot have 2 computers having a 7 there which are on the same network. So that obviously that would mean that the network portion is the same anyway. So a little bit of a problem if I get 2 computers who have got the same IP address and I start getting some conflicts. So if data comes in from the router, it doesn't know where to send it to. Now, how do we know where to divide the subnet mask, where to divide the host portion from the network portion? And what we have is we've got something which is called the subnet mask. So the subnet mask would be, let me just put it up here, yeah, just below this value here. So we've got 255.255.255.0, yeah. And when you sort of tie it up with these octets, let me just sort of align it a little bit better so you can see this. When I tie it up with these octets, you can straight away see where the 0 is, that's your host portion, and where the 255s are, that's a network portion. Okay, if I were to put this into binary, and it might make a lot more sense, let me just do this here. I'm going to put my subnet mask here. And I try to align it with the bytes above a little bit. Okay, so I've got 1, 1, 1, 1, 1, 1, 1, 1. And let me try and align it a little bit better. It's very difficult, isn't it, to get it right when in Notepad it's so easy because every character just takes the same spacing, but it's very tiny and maybe a bit difficult to see. Then right at the end here, let's get proper zeros here, we've got 8 zeros. Yeah. Okay. So how does it work, yeah, with the subnet mask? What we are using is, so again, what I've been saying is wherever the ones are, so wherever these ones are, let me just highlight them, wherever these ones are, that's the network portion, and where the zeros are in the subnet mask, that's the host portion. Okay, all the stuff above the ones is the network portion. So how does it work? It's basically a mathematical operation. So just imagine you've got a corridor with 2 doors, yeah? Two doors, yeah. So first scenario is both doors are locked. Result, you can't get out. So the result is a 0, yeah. Let me just put this down. Okay. Second scenario. The first door is open, but the second door is locked. And the result is you can't get out. So we are still talking about a big fat 0. Third scenario. Just get this right, scenario. The second door is open, but the first door is closed. You still can't get out. Again, stick a 0 in there, so the outcome is 0. Yeah, it's a negative outcome. And then the final scenario is both doors are open. Let me just type this down, scenario. And the result is you can get out. This time you can get out. And the result is going to be a 1. It's a positive result. And I'm not getting the right key. I've got it now. Positive result. So this whole thing is called an AND function. Okay? So door 1 and, let me just use it in capital letters, and I'm going to highlight it as well. Let me just highlight this and click it in bold. And door, actually I didn't want all in bold, just the AND. 2 is open, are open. And that equals a positive result, which would be a logic 1 in our case. Okay, let me just de-highlight or de-embolden the rest of it, and so you can see what I mean. Yeah, we've got the AND function here. That's my AND function. And that's basically what's described here. So when I look at this expression down here, if I've got a 1 and a 1, and let me just do an AND function. First of all, we're going to draw a line underneath here, and now we're going to do an AND function. So 1 and a 1 gives me a 1. So follow the mouse. I've got a 1 here, I've got a 1 there, and if I apply this rule down here, I get a logic 1. So I'm going to stick a 1 down here. I've got a 1 there, I've got a 1 there, and I have to apply this rule here, so I get a 1. I've got a 0 and a 1, and I have to apply which rule? First one is 0, second one is this one, isn't it? So I'm going to get a 0. The same again, a 0 and a 1, I get a 0. And I'm just going to go to the next one. I've got a 0 and a 1, and we've got this scenario here. So that's going to be a 0 as well. And the whole applies for all the others as well. So it's the same calculation. Wherever I get a 1 at the top, I get a 1 at the bottom. Wherever I get a 0 at the top, I get a 0 at the bottom. Yeah. So we pretty much get the same expression. Wherever the 1s are, whatever is on the top goes down to the bottom, applying those rules here. So we've done this. And there we've got lots of zeros, a 1, a 0, a 1, a 0. And now we've got a different scenario because we've got a bunch of 1s underneath the expression, underneath our IP address. So what do I get? Basically, if I get a 1 and a 0, we are now in the first scenario. So we've got a 1 and a 0, still a 0. So all we get is just a bunch of zeros. Okay. And the resultant address will look like this. So I've got 192.168, was a typo, 10, and then we've got a 0 right at the end. And this address is actually called a network address. Why? Because there's nobody in the host portion, and this address is used by routers to route the packets from one network to another. Routers really aren't interested in individuals, they're just interested into networks, and they just route packets between networks, not to individual hosts. Again, that is very important to understand. Okay, so we've done quite a little bit on IP addressing so far. Just to summarize what we have done so far, we have looked at the version 4. We have determined that there's a network portion and a host portion. And we have looked at the subnet mask, which is this one here. And then we looked at what the subnet mask does, so that it's an AND function. You can see the AND function here, so that's all the stuff we've been discussing here. And we get the resultant output as well. Yeah. And whatever we get is called the network address. And that's the one which is basically used by routers to route packets between networks. We have determined a couple of rules. An IP address consists of 4 octets or bytes. The lowest number is a 0. The highest possible number is 255. So you never get an IP address which is 257 or something. That's physically impossible, at least not in IP version 4. To communicate on the same network, all IP addresses need to have an identical network portion. Yeah, makes sense as well. So for all computers on the same network, that bit here, the first octets, depending how many octets there are within the network portion, whether it's 1, 2, or 3, they have to be identical. And the value for the host portion has got to be unique, so on the same network. So this number here has got to be unique. You can't have two computers with the same, because effectively it would be the identical IP address with the same value in the host portion and the same value in the network portion. So it would be a little bit like having two people with identical fingerprints, with identical everything, to a clone of one another, or two clones, and it wouldn't work very well. As far as networking is concerned, you would start having problems. Okay, so that is the first lesson about IP addresses. Just a little bit to bear in mind. I'm going to take it one step further, and then we'll be looking in the next lesson at subnetting and what we can do with IP addresses. Okay, let me just get you a couple of pointers. So Google, always a good friend. You can always use them. And let's have a look what we get. Classful. Okay. So we're just going to look through Google, see what we can find. So we've got Wikipedia is always a good starting point. We've got a little course here. Let's have a look at Wikipedia. I'm going to look, for now, just at classical IP addressing, and I'm quickly going to talk you through. So these are the different classes. Can I view this up a bit? No. Reload back to zoom in just a little bit. It won't let me do this. Okay, let's try to do it the way it is right here. Or let me see whether I can copy it. Then we can make it a little bit bigger and hopefully a little bit easier to read. Okay, let's have a look. Yeah, not much, but maybe you can see it a bit better. So we've got a couple of classes of IP addresses. We've got class A, class B, and class C, and they're the important ones you'll be likely to deal with most of the time. So what have we got? We've got a typical class A IP address, starts with 0. That's a start address. Over here they say it's 127.255.255.255. I would say it's 126.255.255.255, but it depends what book you are buying, what book you are reading. They give you different information. Now, 127 is a loopback address. Let's put it down in our little list here of rules. It's number 6, yeah. 127 dot, I'm just going to put dot access in there because it could be any value, is a loopback address. I got caps lock on, loop back address. Okay, so you can't really use it for a host, but all you can use it for is to check out, what's happening with your computer and whether everything is okay. So let's do a little demo to show you what a loopback address is. So if I type in ping 127.0.0.1, I'm basically pinging myself. That's all I'm doing. Yeah. So I can use any other number. So I can use maybe 1 to 112. Yeah. Still works the same way. So anything starting with 1 to 7, other than 1 to 7, 255, 255, 255, or 1 to 7, 0, 0, 0, is basically a loopback address. So you're just pinging yourself. So it's a bit like checking whether you're still there, whether your network function works. Let's try it with just 0, and you will see it should not work. Yeah, so it gets a failure because it's a network address. And the same if I type in 255, 255, it should not work either. Let's see whether I'm telling the truth or not. It's hanging, it's thinking about it. And it times out, yeah. So 255 would be a broadcast address, so it would broadcast to all the computers on the network. So for example, if I'm just going to try it with the IP address I'm using, and I can show you what a broadcast address does. Okay, first of all, we do an IP config. Yeah. And I can find the IP address my machine has picked up. So it's 202.223. Okay. So let's do ping 192.168.200 and 255. So I'm now going to ping every machine in the network, but only a few machines should answer. And that is 203. I'm not quite sure which machine it is. Normally a broadcast, it's not myself, is it? Let's check it. No, it's not my address, it's something else. In the past it used to be our DNS server which was connected, or which had this IP address. Now in the new building I'm not quite sure, it might be anything else. Normally a Microsoft machine does not answer, but let me see whether it routes it through. But a Unix-based machine will answer to an IP broadcast. So basically we have found one Unix machine on the network. I'm just going to try our classroom network and see whether we get any response from there, whether it's routing pings through. It's not, yeah, so that doesn't work. Oh no, sorry, I got the wrong network. Let me just try again. It's not 100, it's 10. Okay, and you can see you get a reply from a couple of computers, and the suggestion is going to be that this is going to be a Unix machine. I think it's a printer. Okay, let's move on and have a look at our IP addressing scheme. So we've got class A IP addresses starting at 000, going to 126, 255, 255, 255. Then we've got, this is assuming that you don't include the Loopback address as part of the class A IP address list or scheme. Also very important to notice that it's only the first octet, the first byte, which is used for the class A IP address. Yeah. The 3 bytes are used for the host portion, and the interesting thing is, if you use 3 bytes for the host portion, this is a number of hosts you can have per network. So you can have about 16,777,216 hosts per class A network. There's also a private class A IP address, which is 10. Yeah. Let me just put this down. Private IP addresses. You can use them on any private network. You need to enable NAT before you go into the internet. So the only guarantee you have when you use private IP addresses is that they're nowhere used on the internet. So you're not going to be unable to suddenly connect to certain web servers or web resources. Private IP addresses are the following. So we've got 10. Yeah, that's a class A private IP address, and then it could be anything. The subnet mask is 8 bits long. That's why we put the number 8 there, so it's just 255. The next one is, so we've got, let me just put this down, class A. For class B, we've got the following. Let's put it down, so we private IP addresses. Do it slightly different so it's easier to see. So we've got class B, that's 172, 16, and then this octet can go up to 31. So anywhere in this range you can have like different networks, and then we've got X and X. Yeah? The subnet mask is 16 bits long, so we can put there /16, so we've got 255, 25500 as a subnet mask. And then we've got a class C private IP address, which is 192.168. Then in the network portion, we've got 255 or 256 different variations we can go for. So that's an X in the network portion, so you can have different networks with your class C address. And then we've got our host portion, and we've only got 254 hosts per network. Then the subnet mask is going to be 24. So it's going to be 255, 255, 2550. 3 255s, 10. Okay, and these addresses can be used on any private network, providing you use something which is called network address translation. So your network will, let me just change this slightly, become invisible to the internet, and you only get through to your computer whatever you request, but you don't get uninvited guests coming and sniffing your system out. Okay, let's go back to the table. And in this table we've got class A, class B, and class C. You can see class B starts from 1 to 8 and goes all the way to 191, 255, 255, 255, yeah, as the end address, the last possible address you can use. And then we've got class C, which is, I'm not quite sure why they put something there in the host portion. That would just be a broadcast address, really. But anyway, it's just a guideline, really, so don't worry too much about it. Class C, we've got 192 to 223, and then right to the end of the spectrum. And then class D is a multicast address. And class C is reserved for experimental use. Okay, and straight away you can see that there's a problem. A lot of IP addresses are pretty much thrown away and they're not available for use. Okay. What else do we need to know about IP addressing? I think these are the main points. You need to get your head around it. The most important thing is, and this is where a lot of people are getting it wrong, is which one? That one here. Okay, every IP address has a host portion and a network portion. You need to make sure you know which one is what. You can use any IP address for any network, providing you make sure that the network portion is the same. And that's number 4 and number 5, providing those 2 rules out here too. Yeah? So then you can make pretty much anything work on a network. If you use a private network, don't use just any IP address willy-nilly, but use these addresses you can find here. I'm going to give you a last bit of information, and then I'm going to close this lecture on IP addressing, and the next lecture goes a little bit deeper into binary and then also into subnetting, which is a little bit more horrendous. Okay, one IP address you sometimes see, it's not really a defined one, it's just Microsoft uses that one, and I've seen Linux machines using the same one as well, is 169.254 and then something and something. Yeah. This IP address is a so-called APIPA. Sounds a bit weird, but all it stands for is Automatic Private IP Addressing. Now, what's happening is if you turn on your computer and your computer uses something which is called DHCP. DHCP is when your computer turns itself on, it realizes it hasn't got an IP address, and when you go into your network settings, let me just go in there, I can show you how this works for real. Okay, let's go into this adapter here. Go to Properties, and where are we going to go? We're going to go to TCP IP version 4. And if this is selected, obtain IP address automatically. So I haven't configured an IP address in my computer. Then it requires that there is a DHCP server on the network. If there's no DHCP server on the network, it'll force itself this IP address, 169.254 something something. So it's almost like a random thing. Checks out whether the IP address is used somewhere else, and then it allocates the IP address to itself. The subnet mask for this one is 255.255.0.0, and there's nothing for the default gateway, nothing for DNS. And what will happen is your computers will be able to communicate on the local area network, but they will not be able to communicate via a router because there's no entry for the default gateway. Okay, just bear this in the back of your mind. So if I do an ipconfig, let's go back and do an ipconfig. I would, if the DHCP server didn't kick in, I would see 169.254 and then a number and another number in my command prompt, or after my command prompt. If I use the command ipconfig, you can see this here. That's my ipconfig command. And then straight away, pretty much you know that something has gone wrong. Maybe the network connectivity is down. Maybe the DHCP server is down. You've got a problem somewhere and you need to fix it. Otherwise, you won't be able to go on the internet and possibly even authenticate or go on somebody else's computer. Down here, just a little bit on a side note, you see a DNS server address. Now, a DNS server is a server which has a massive database, and the database will give you an IP address for a domain name. So, for example, if you type in www.google.co.uk, it'll go to the DNS server. The DNS server will know the IP address, and it'll send the IP address to your computer, and then the computer is going to take the IP address, go on the internet, and access Google or any other search engine, Yahoo, Microsoft, Lycos, web crawler. I'm not quite sure which of those are still around, but there are other search engines as well. The next one is this DNS number here. So this 88888, easy to remember. If you live in Asia, 8 is a lucky number. And this means that this DNS server which I'm using here is actually the Google DNS server. So I can use another DNS server. In this instance, I'm using Google. And it might be worthwhile as well. So if you suddenly use internet connectivity, instead of obtaining DNS server address automatically, just force your own DNS entry in there, your DNS IP address, and put in 8888. And you can maybe eliminate a problem. So if it works, if it doesn't work on 8888 either, it's most likely that you've got network problems. If it works on 8888, but it doesn't work with your local DNS server, then obviously your DNS server seems to have gone down or there's a problem somewhere. Okay, I hope this little talk was helpful. That's sort of general chit-chat about IP addressing. The next talk will be about numbering system, and where we look a little bit on how this stuff comes all together and how we can translate from one to the other quite easily. And then we'll be looking at subnetting as well. Okay, thanks for watching this.